Hello, world. If anybody is watching, welcome to the Aero-Gro DIY aeroponics and hydroponics lab. This is going to be a regular program. Basically just me hanging out in the lab doing my work. I'll share with you what I can. Yep, I'll hook this up. See if I can see what's going on the live view. Hmm. All right. I don't know why that's not working. I'll have to figure that out later. All right. No dropped frames. That's good. All right. How do I display? It's 2 amps. Good enough. Yeah, there we go. Let's see here. $12 volt 2 amperes. That'll do it. Hello, sir. How many amperes would you like? Oh, that many? Shocking. Okay, let's see here. Let's put this up here. Let's test. Okay. If we, let's see here. Let's do some electronics work. Hey there, open it. Hey, are you like Scandinavian? Opa? Yeah, I think that's like Scandinavian for grandfather. I'm not sure. I might be making that up. Okay, let's see here. I'm going to get this out of my way. Put something else in my way. And get out of my own way. Okay. The mouse. The meter. You know what? Let's get this out of the way too. Do, 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 do. Do, 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 do. All right. So if I'm on YouTube and I'm singing a well-known song, do I get in trouble? Do I get a copyright violation or something? All right. So soldering iron hot. Okay, so what we're doing today is I'm building a 2-bucket system for a customer in Missouri. And today, putting together actually 2 controllers, one for the customer in Missouri and another one for an upcoming project. Not in Missouri. Let's see. No, I replaced this one. This is older style. Nope, that's not right either. Is that the one? Yes, that's the one. Cool. So something you will probably notice, anybody who watches this channel or checks out Aero-Gro ever, is that each project tends to be kind of custom. So these controllers, for example, are different than the usual because customer needs a slightly different design. Let's see. Oops. Let's go with, switch this camera over to Skycam. Yeah. All right. Sure. Let's see here. Take the back off of these. And I wonder where she's gone. All right, I won't sing. That's really obnoxious. Okay. Very interesting, Mr. Bond. All right, I'm going in. Now, the good thing about being in love with thumb screws like I am is that it's easy to take everything apart. Adjust this camera. That's a little better. Okay. Yeah, thumb screws are great. They allow you to just take everything apart really quickly and swap out any broken parts and clean it really quickly. And yeah, there's a lot of advantages. Okay, now I can see, yes, these have not been waterproof yet. So instead of waterproofing them right at the moment, I'm going to swap them out for a few that have been waterproof. But all of this, of course, depending on me finding a screwdriver. All right, seriously give up. Where's my screwdriver? Where? Where's my favorite? Oh, there it is. I have about a bajillion tools, but I only have like 25 or 30 that I actually use every day and that I actually like. Yes, these are waterproof. I don't know if you can see this on camera, but the one on the left does not have waterproofing. The one on the right does, and you can see kind of a shiny material on the board. You see the edge of it? Glaring, the light's glaring off of it. Right there, that's the waterproofing. The left one doesn't have the same thing. Oh, if I had my UV light, I could show you this really easily. I don't have it right here. Wow. Yeah, so these are waterproof. I'll pop this out. Go. That one needs to be waterproof. That's a shame. I was just doing a whole bunch of them the other day. I could have done those, but I didn't know they were sitting in here. All right. Those get done on Monday. Waterproof. Boop. Yeah. Let's just like this. Yep, that's good. Now I just want to swap this one out. I didn't remove the protective covering off of that. I'm gonna have to go back and do that. I knew something was wrong. I couldn't quite tell what it was. Okay, there we go. Just made another mistake. Okay, these are upside down. My bad. There we go. Now, what I do is, because these timers have to be pushed all the time, I like to put a little hot glue on the inside to secure the timers in place because it just makes them more stable and it gives it a little better tactile feedback when they're very, very stable in this case. If they're loose and wobbly, when you go to push a button, it kind of moves the entire timer a little bit. It just doesn't have the same feeling. It's kind of the difference between closing a door on a 1965 Volkswagen Bug and closing the door on a brand new Mercedes. It's a different sound, it's a different feel, you know, go for the Mercedes. Okay, we'll turn on the glue gun here. Where's my glue gun? I just moved it, there it is. Now what I do, once this is in place, is I'll go in and I'll put, I'm not going to do it right away because I still have some soldering to do, but ultimately I'll be putting glue right in the corners here, right here, over here. This is on the outside of the timer's case. Between the green plastic here and the gray plastic is where I apply the hot glue. Right in here, just a dab right there, a dab over here, a dab right here, and a dab right here, and the same one on the four corners of the other timer, obviously. Okay, but for now, I'd rather show you how I wire this. Okay. I do this a lot. All right, let me show you a few things here. I'll just sort of talk out loud as I go. That's going to be the deal as I do this Aero-Gro lab, is I'm just going to talk out loud as I work. I talk to myself anyway, so might as well be talking to you. Okay. Solder, flux. And then, you know, I'll be doing like nutrient mixing and all kinds of stuff. Today I'm doing this. And this is a case you're not familiar with the channel or whatever, this is a controller for an aeroponics system. There is a timer, what's called an interval timer, for the nutrient spray cycle. And then there's another timer, a second timer, which returns the sprayed nutrients, which are then on the bottom of the grow bucket, back to the nutrient bucket. And just the timers just do that over and over and over again. They spray and then return, spray and return. So what I do with these timers, this is a little pro tip here. These gizmos and gadgets have very kind of small, finicky, screw type connectors here, right? So what I like to do, instead of trying to jam 4 or 5 wires into each one of these tiny little connectors, is simply take a piece of what's called bell wire, which is solid copper. Let's see if I can show you this a little better here. You go piece of wire. See that? Piece of what? I'm still getting used to this camera. There we go. Piece of wire. And then I'll insert the wire into the terminal, and then I can solder as many things onto this as I want. And then there's only one connection that's a really good connection to the timer itself. I'll show you. Okay. Loosen up these, ooh, cut myself. I'm always cutting myself and I never know how it happens. It's very strange. Let's see. I'm sure a psychiatrist would have a field day with me. So, tell me how these accidents keep happening. All right, so then I loosen them up, take a single piece of wire here, put it in the terminal for the positive power in, which is labeled as VCC on the board. That means positive power in. You know, come to think of it, I don't know what it stands for, VCC. That's a trivia question there. If anybody knows, put it in the comments. I do not know what VCC stands for. Okay, tighten that up really well. That's another pro tip. Don't be afraid to really torque down on this. Since you're only torquing down on one single wire, you can do that. Just be careful, don't break it, obviously. But once you go to tighten it, you really want to tighten it. And that will be your permanent connection from that point forward. So you got to make sure it's a good one and do it again after you're done with all your soldering, because these have a tendency to loosen as you're working on them. Okay, so pro tip, before you button everything up, close it all up, tighten everything down again, just to make sure. Remember, with aeroponics and hydroponics, it's very automatic, it's very easy, clean, yada, 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 but you need to do everything you can to ensure that there are no catastrophic failures when you're not looking. So tighten everything down and double check everything. You should be just fine. All right. Yeah, in your garden, if you forget to feed the plants, it's okay. There are nutrients in the soil. And that's not true with aeroponics and hydroponics. You have to do the feeding. So I tell everybody, not everybody, you know what I mean. When I talk to people, I say, well, because people say, how hard is it? They ask, how hard is aeroponics and hydroponics? I said, well, it's not hard at all, but you have to remember that your system, whatever you buy, should take care of the automation of feeding the plants, you know, so you don't have to be on top of it all the time. But it's up to you to prepare their food. And then you let the system do the feeding, if that makes sense. Yeah, so you're the chef And then you pass the food on to the butler who then feeds your plants. That was a terrible analogy. Sorry about that. Okay, now what I'm doing now is, since I have to make a little jump from the negative input terminal over to the relay over like a bridge, I'm just creating literally a little, hard to show, a little bridge, a little wire U-shaped bridge, which will connect the negative and one side of the switch for the relay. Oh, there's another pro tip. When you are switching an electrical signal that's going to run a pump or a fan or a light or anything at all, it's good practice to switch the negative line, not the positive line. Now, with low current, low voltage like this, it's not a big deal. But with higher voltage, it can be a big deal because, from what I'm told, and I'm not an electrical engineer, but I'm told that there's less of a chance of arcing and sparking when you're switching the negative rather than the positive. Switching the positive, click, 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 on and off, it creates sparks. And that sparking can create a short or can lock up the switch. It can literally weld itself to itself from switching on and off at a high current. So if we switch the negative only, it doesn't spark like that, and then there's no chance of the contacts welding to each other. Hopefully that made sense. So switch the negatives, not the positives. Okay, let's see. It's a good rule of life. Change the negative stuff, not the positive stuff. All right. Enough philosophy. More hydroponics, less philosophy. Thank you. All right. Now I'm hooking up a bell wire to the terminal that ultimately will be the switched on output from this relay. So this is the electrical signal that will be turned on after the interval has run out. So let's say I want to feed my plants every 3 minutes. I set my timer for 3 minutes, and then after 3 minutes, the timer will turn on for however many seconds I tell it to. Let's say 10 seconds. So every 3 minutes, it turns on for 10 seconds. And during those 10 seconds, the electricity is being passed to this final terminal here. This is the negative, remember, going to the pump or the fan or the whatever. But that's the wire that's turning on and off, or getting power sent to it and then cut off, sent to it, cut off, so forth. That wire. All right. So, and that's just the output wire. I don't think there's any fancier name for that. So, you know what? I'll put some schematics up on the website, and I'll put a link in the description so you can check out what it should look like when it's done as far as the electrical schematic. There we go. Now, okay, now, this is cool. We have easy to work with, or easier to work with, terminals here. See that, those wires? That's going to be a lot easier to solder to and to work with than trying to jam all the wires into those tiny little holes and then trying to screw down onto that messy wire cluster. Never going to work. This will work great. I know it because it works great every day. All right. Let's cut that. Trim, trim, trim. Always nice and neat. Oh, another pro tip. When you are trimming wires, anything like that, anything copper, anything electrically conductive, trim it away from your work. Over here. over there, over there, somewhere other than where it's going to fall back in and do some damage. Snip, let it fall. Snip, let it fall. Okay, whatever. But yeah, protect your work. All right, let's do the second one. I'll move a little faster because I already explained it. Okay, trim the bell wire. And when I make these units for Aero-Gro, I'm always trying to find ways where I can make them the same way every time, find the consistency between them. Once you find a new way of making something, it's really important to kind of start doing it that way. So I work that into my process. And if there's a new and better way to do it and it's been tested, it becomes the way. Created my little bridge first. No particular reason, just because I felt like doing that first. Some pliers here. Get a grip on this. Get a grip. There we go. Oops, I didn't loosen them up first. So yeah, when you get these, when you order these off of AliExpress or wherever, they're going to be all tightened down when you first get them. You're going to need to loosen them up just a bit, just like that. Yep. And then you can put this in there pretty easily. Little finicky. Finagly. Fumbly. How many words are there for that? Finagly, fumbly. I don't know. Probably some other words. I practice my Yiddish as I'm working. All right. Bend over. Oh, by the way, what I'm doing here every single time, I'm taking a straight piece of wire, gripping it with the pliers, and then bending it over like a hockey stick, like that, like that, yeah, right? And then that's getting placed into the contact there. Sometimes. That needs to be a little looser. Like that. That. All right. And make another hockey stick. Ooh, loosen that one up a little more too. There we go. All right. Trim, trim, trim. Remember, trim away from where you're working. Let me show you that. How do I do this? Let's see. Okay, I'm just making sure I'm not near anything important. Let's say right here is an area that's where there's nothing important. Then I would trim right here. Here we go. Trim right here and then let it fall down here so that it's not falling back in here and short-circuiting something, which actually in this case wouldn't happen because this has been waterproofed. It literally has a plastic coating on it, but nonetheless, trim away from your work. Yeah. All right. Now those are ready. Whoops, almost ready. I forgot to tighten this one. Put that back in. Now we're ready to do some soldering. Get in there. Get on in there. There we go. And remember, you're going to tighten again when we're all done, so you don't have to be totally aggressive and before you solder. All right. Now we've got 2 ready to go timers. This is the 3D printed case for the timers, but you know, this can be made out of anything. I mean, this could be a piece of cardboard if that's what you had to work with, or a piece of really thin wood, or if you're into 3D printing, you could go into SketchUp and do something up and print it. That would fit the measurements of this timer and pop them in there and get going. There we go. Like that. Now, if you're going to do your own designing, don't be disappointed if it doesn't fit this perfectly at first and click into place and all that. It can take some practice to get the 3D printing under control. All right, let's get this tightened up. And what I do is I put power inputs on everything so that there's no chance of short circuiting. Everything has a plug. Everything is polarized. That's important too, because if you have, multiple plugs, it's possible to plug them in incorrectly. But if you polarize them, where a male only goes into a female, so forth, then you can control that a little bit and minimize the risk of connecting it wrong. I'll show you. There we go. Okay, nice and tight. Now, heat up the soldering iron. And where should we begin? Let me show you. Okay, one little trick that I do here, kind of neat. I just started doing this recently. Is let's say you have to feed 12 volts positive to both timers, and the lead is coming off here from your power. Instead of cutting 2 pieces of wire, one going to each, cut 1 wire and loop it. I'll show you what I mean. So sort of measure it out roughly. If it was going to take that path, it would go around here. It'd probably just loop back. I mean, do it however you want, but this is how I choose to do it. Loop it back and then over to here. There we go. So that's how much wire I need. Show you. Here's another thing. The wire with silicone sleeving, jacketing, is very easy to work with because you can just use your fingernails to pull off the insulation. See that? Like that. Yeah, I mean, it's like really easy to work with. Just pinch it like that. Pull it right off. Can you see that? Hopefully you can see that. Yeah, like that. Okay. Twist. Like that. Now, here's the trick. I solder one end first, and then I wrap around, and then I separate the insulation where I need to solder it in the middle, and then I solder the final end. Show you. Solder the first end. Also, I pre-tin all of my wires. I'll show you what that means. Just take your brand new twisted wire here, twist it again, melt a little flux, make a little pool, dip it in there. And then also keep your work away so you're not boogering it up accidentally. That pre-tin. And what that means is I created a little pool and melted a little bit of rosin there. Just made a little pool like that. And because it melts when it gets hot. And then when I have a wire to tin, for a few minutes anyway, that'll stay liquidy. Dip it in there, swoosh it around, smoosh, swoosh, schmutz it, There's the Yiddish again. Schmutz it. Schmear it. Schmear some on there. All right. And then come back here and try not to burn the house down. There you go. Like that. Melt to let. Oh, and remember another pro tip. Not really pro tip. This is basic soldering, but you do not heat the solder. You heat the part, and then you let the solder run into the part. So solder is just sitting here, sitting there with a piece sticking up in the air. I'm coming over here. It's still sitting there. I'm not touching the solder. I'm heating up the wire, and then I'm lightly touching it to the solder. And then it's just boop, running right into it, just like that. It's finding its own path into the wire, okay? Because it's hot and melty and runny. Then, come back here, trim the end off just to make it neat. That. Like that. Yep. And then we're going to solder that to the positive. But before we do, I'm just going to put a little solder dab on the end of this power connector, pre-tin it. Again, try not to burn the house down. But if you do burn the house down, let me know how it turns out in the comments. All right, let's see here. Trim that. This to the end. I am soldering to the positive terminal. Again, I'm heating the terminal, not the solder. Letting the solder run where it wants to go. Oops, having a little trouble here. Need some tweezers. Or needle nose pliers, rather. Very tight space. There we go. All right, that's on. Now, this little thing I was telling you about, this little trick, pro tip. Now we have the wire long enough to run all the way over to the other timer to wrap around its positive in and then run back. So what I'm going to do, I know that I need to strip the wire right here to expose some copper, but I don't need to take it all the way off. All I need to do is create a little opening right there. Let me show you that. Just like that, right? Just a little opening between the insulation. All I did, because it's nice and soft, I took my fingernails and I just stripped it. I pulled both ends apart from each other to create that little exposed area. And now I can take it and wrap it around this and then solder that. It eliminated a step. I didn't have to cut 2 wires. I only had to cut 1. And when I go to solder other things onto this post, they're not all going to want to go everywhere. It's wrapped around the post. So once that's soldered, it's there to stay. That's where it lives now. Good to go. I love it. All right. So push that down a little bit and then solder it. Also, I have to push this down a little further because ultimately I need to put a top on this, or a back on this controller. And if I don't push it down far enough, it's going to prevent the back from going on. There we go. Okay. Now, bend this over so the top will close. And that's what it looks like. Nice and neat. See that? And now I can take this and I can simply run it over to this post and do the same thing. I'll wrap it around a few times and then solder it. Strip off a little extra insulation. There we go. Twisty, twisty. I'm going to run it the same way here. Then I'm going to wrap it. Now, I wasn't thinking because I was on camera, but I actually wanted to leave one of these ends untinned so it was easier to wrap around the post. Now it's actually stiff because I tinned it. I'm just going to strip a little bit off. Redo that. Twisty, twisty. Now I can wrap it, or oops, a little more off there. Twisty, twisty. And wrap it around. Also, make sure you don't have any wispy single strands of wire hanging out anywhere because that could short out and cause you a problem. There we go. Ooh, cutting it awfully short there. It's okay. It's going to work. That is really close. That's all right. All right, there we go. Okay. Heating the part, not the solder. Let the solder flow. Good. Whoop. Not quite. A little flux there. Flux, what this does, or rosin, also known as flux, what it does, it's chemical. And when you melt it, it flows over your solder joint and protects the solder joint from oxidation, because oxidation will prevent a good solder joint. So just temporarily prevents oxidation until the solder joint has been created. And then its job is over. Your job becomes to then clean it off. Yeah. Okay. Done as far as the positive pole there. And it's really secure. It's really neat. And it's routed nicely. It's not going to cause any problems. Good to go. So now we're going to do the negative side. Remember, that's the one ultimately that's going to get switched. And then that negative line is going to get run to our pumps, 2 pumps, spray pump and return pump. Piece of black wire here for the negative. And I'm going to do the same thing as before. I'm going to run a single wire to both timers. Just twisting that so I can see it, the our jack. Let's go in this way. Melting a little solder, or flux, sorry. Now, solder this onto negative terminal of the power input right here, the jack. Yep. Oop. Nope. Good. Now I can run this negative wire. How are we doing here? We're still on air? Probably. Probably not. All right. So, oops. All right. Let's go to YouTube. Sorry, just gonna check that we're still working okay here. Cool. Let's see here. Yeah, we're still working. Good to go. Whoops. Yeah. Oh God, I'm missing this chat here. Sorry, everybody. All right, there we go. I'm just gonna keep on going. Dry fogger you had in one point. Yeah, guys, hold on, let me see the comments here. All right. Government just announced cannabis legalization for April 1st. Hopefully no joke. Yeah, I know what you mean. It seems like there's a lot of misinformation. United for School for Engineering. Nice. Looks nice. Thank you. Thank you. Appreciate it. From a real engineer. Thank you. I'm not a real engineer, by the way. Well, I mean, I'm an engineer because I decided to teach myself, but I didn't go to school for it. Yes, the dry fog. Okay, Andrew Bello. Okay, here's what I want to tell you. I have some good news for you, my friend. Let me just do something really quick. I'm going to take these headphones out because I hear like 57 voices. Okay, there we go. All right. Andrew Bello, yes, the dry foggers. What I could tell you about that is that I have a source now for okay, start over. There were two versions of the dry fogger from the company that makes it. There's a plastic version and a metal version. This is from the manufacturer. Plastic version and metal version. And the plastic version is the one that I picked up a few years back and started working with. I'd never had the stainless steel version. There's a stainless steel version, a plastic version. And then they, as you pointed out, they stopped manufacturing them, which was heartbreaking, let me tell you, because I built like a bunch of systems around these sprayers. And then they just stopped making them. I honestly have no idea why they stopped making them or were no longer able to get them. Anyway, long story short, I kind of died a little on the inside when I heard that, and then decided, okay, well, you know, what are you going to do? This kind of things happens all the time, so you deal with it and move on. And that's what I did. I found a different type of dry fogger that was a little bit different. It was made out of stainless steel and not based on exactly the same technology, but there were a few things about it that I liked actually over and above the dry fogger that I had first been using. The new ones that I found as a replacement were very adjustable. I could adjust with a little bit of modification, I could adjust the amount of air coming in and the amount of nutrients coming in. And they were, you know, I was able to work on it. It was like buying a car that you're able to work on. It was very similar. The original ones, the plastic ones that you're referring to, you can't do anything to them. It's a very effective dry fogger head, but then they stopped making them, but it worked really well. And like I said, I was sad. So recently I got on the phone with the company that originally had made those dry fogger heads. And I'm like, yo, what's the deal? Are these things ever going to come back? I need some closure, you know, because I kept thinking about them. It was really crazy. And the guy said, oh yeah, I'm going to be getting more of those in. And I still don't know the story behind it. Something happened and the manufacturer, I'm assuming, had to be changed. So in other words, there's a manufacturer who's the one who's selling it to the world, but there's also a factory, right? And that's technically also a level of manufacturer. And on the factory level, they probably had to switch. They probably had to find a new I'm guessing. They probably had to find a new factory. And that can take time. That can definitely take time. And you have to retool. You have to pass on the intellectual information for the new factory to be able to make the part correctly. There's a lot of stuff involved. So the good news is they are coming back. I will be selling them. I'm already in negotiation with the company that originally made them. And with any luck and a little bit more time, I should be able to offer those to the public, as well as, and this is kind of cool, as well as all of the other sprayers that I developed as not developed, but the other sprayers that I started using as a replacement for that first one, they will be available also on the website, because why not, right? I mean, then we'll have the originals and we'll have all the new ones that were figured out in the in-between time. So yeah, I'm really excited about some of these new products that I'm able to bring to you guys. And that dry fogger head has got to be one of my favorite products. It is just awesome. And the reason it's so good, not to put the others down, the others work very well, but the reason I liked it is that it was a patented design. The plastic one, patented design, very, very unique in the way that it created an ultrasonic effect. It shot the nutrient solution through it so quickly using the Venturi effect, or I don't know, a couple different things they were doing inside. It's kind of voodoo, but it created such a fast flow of nutrient solution and air that the corresponding droplet size was very, very small. And that's because they achieved speeds that were ultrasonic. They were beyond the speed of sound. And that is amazing. And the droplet size was fantastic. It was very uniform. The droplet size was very uniform. The spray was very uniform. And they were very quiet. That's the thing that I really found special about those fogger heads, is that they were extremely quiet. Because some of these others, the stainless steel ones in particular that I've been using as a replacement, they work really well, but they are not as quiet, definitely not as quiet as those plastic ones are. So very excited about the opportunity to bring those back to the market. And quite honestly, I'm looking forward to the opportunity to use them again myself, because I really like them. So yeah, stay tuned for that. Good times, good times. 2024 is going to be really cool. There's a lot of things opening up, and I am open. By opening up, I mean there's a lot of interest in this country for growing right now because of cannabis opening up legally, and cannabis being recognized as a legit medicine. There are a lot of things going on that make the timing of the products that I make here really pretty good, I guess. So yeah, it's exciting. 2024 is a big year for all of that. So here we go. Strap on your seatbelt. All right, there we go. Now we have positive and negative hooked to the timer. Now what's going to happen is if I hook up a power supply here, our timers should turn on. That's all they're going to do. They're just going to turn on. They won't do anything yet because I haven't hooked up the output, which is then going to run to the pumps. Let me get a power supply here just to test it. Mm, 12 volt 2 amps, that'll do. Yeah, so let me just mention really quickly these pumps that we use, at least here at Aero-Gro. I don't know what other people use, but this is what I use. Let's see here. There are they're basically two variations on the pumps that I use here. One of them is to supply the nutrient solution without the addition of air, just pressure. And that's one of these bad boys here. And this is a 5 amp pump, 60 watts. And it requires a 5 amp power supply. The controller, however, only requires a very, very, very small amount. So what I do is I get the power supply big enough to supply the pumps, and then automatically I have enough to supply the controller. So no problem. I hope we got one on. What happened to that one? Negative, positive. Loose connection. Yeah, negative. That's there. That's there. Up. Ooh, did I? Let's see here. Nope, that's good. What did I do wrong? I did something wrong here. Let's see here. Oh, I probably have a loose connection. Yeah, I thought so. This one felt a little wonky when I was attached. touching it. Ugh, yeah, it just fell right out. Okay. Yeah. Yeah, let me redo this one real quick. All right. Yeah, I'm just going to redo this connection real quick. I don't like the look of that. Sometimes that happens when you do stuff on camera. You wind up, going off script a little bit, or how would you say that? Skiing off the trail a little bit. And you wind up making a few mistakes because you're thinking too much about the camera and not enough about what you're doing. So sorry about that. Let me just make a correction here. Quick. Making one of those little U-shaped doodads here. All right. And then we're going to loosen up our terminals again. I'm going to separate the little U-shaped doodad from the wire because I want to redo it. Should be easier if I just cut that. Come on, there we go. Sometimes I feel like a surgeon. All right, let's see here. Let's get this back in there. I'm just sorry. I'm just looking at the YouTube, make sure we're still live. Yeah, looks like we're okay. All right. Where my pliers go? There. There we go. Loosen that up a little more. Yeah, this one's giving me some trouble here. Let's see. There we go. There we go. Yeah, that wasn't seating properly. Seating properly. All right. Hopefully this will take care of it. Let's see what goes on if I just temporarily hook this up and bottom one's good. And yep, that's it. Yep, that was it. Okay, so now that I know that, let's undo this. Run this under. Unplug. Yeah, that would have been a pretty sad mistake if I'd forgotten to unplug it. All right, send this through. Resolder. All right. Good. All right, and sending this back over to here. There we go. Yeah. This is how we do it, baby. Oh, no singing. I forgot. All right. No singing in the lab. If you sing in the lab, we're going to do terrible things. Terrible things in your dreams. What am I going on about? I have no idea. Don't mind me. I just talk out loud and babble a lot. Okay, there we go. Positive, positive, negative, negative. So now we're going to plug this in, and with any degree of luck whatsoever, both timers will turn on. And da-da-da-da, there we go. All right, so now we are going to hook up the manual operation switches. So top timer, excuse me, controls the big pump here that sends the nutrient solution. The bottom timer controls a smaller diaphragm pump right here. It's actually, oh yeah, I can show you that. Yeah, one side has the small diaphragm pump. The other side has the main pusher pump, spray pump. And both of them obviously are hooked up to this. And what we're going to do now is run the wiring that ultimately runs to the pumps and turns on the pumps. On the front of your controller, you have a button for each one of the timers. If you push the top button, it will manually turn on the spray pump. If you push and hold the bottom button, it will manually turn on the nutrient return pump. This is for when you're setting up the system and you're priming everything and getting the nutrient solution to go through the tubing and then to come back through the tubing back to your nutrient tank. These buttons help you to prime the system to get it up and running. That's what they're for. They're just used when you're setting up or when you're testing or anything like that. These buttons will help you during that, okay? So what we're going to do is unplug this again. And you remember the electricity that's going to run the pumps is passing from the negative side here over to the N terminal. We're passing the negative, not the positive. Positive is only running the timers. That's all it does, run the timers. And then the positive goes to the positive terminal of each pump all the time. But the negative is what gets switched. The negative to the nutrient pump and then the negative to the return pump. That's what gets switched, okay? So that's what we're about to do. So in the top one here, what we're really doing is between the third terminal and the fourth terminal, which is the one that closes during the timing cycle, after, let's say, a minute, if you want it to run for, let's say you want your timer to run for 10 seconds every 10 minutes, then every 10 minutes it'll go click and turn on for 10 seconds, and 10 seconds later it'll click, open up and turn off. 10 minutes later, click for 10 seconds, and then click to turn off. That's what it does. And it's this part, click, 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 the switch is these last two terminals here, right? Okay. Same for both timers, the last two terminals and the last two terminals. That's what's getting switched. Okay, so to manually operate them, all we have to do is bridge these two terminals with this switch. Bridge these two terminals with this switch. And that creates the manually triggered function. Hopefully that made sense. That was a lot of information. I don't know how else to say it, but I will try to find other ways as we go. Okay, and a picture's worth 1,000 words. So here it comes. Just gonna cut a little piece here, strip this, strip a little more, strip that wire. No strippers in the lab. Okay, here we go. Get some wire here. Now I'm just going to, as usual, we're going to tin the end here. Create a little pool, dip into the pool, just the toes. There we go. And solder the end there. Tin that puppy. There we go. Now I'm going to go over to the terminal, the end terminal. I'm actually going to pre-tin that terminal. Much easier to get the solder connection to work well the first time if you pre-tin your target terminal. It just gives you like a nice melty pool to jump into, like that. Nice melty pool. Yeah, it's good stuff. All right. Melty pool straight ahead. Hope you brought your swim trunks. All right, let's feed this over to the switch. I'm just going to cut a little piece here. Trying not to tear up my own work here. There we go. Twisty, twisty. Again, away from your work area. Don't solder over top of your board. Do not do it. Just come on the, whoops, clean this off a little bit. Come to the outside. Where's my sponge? Sorry, one sec. Got to keep the solder tip clean or your life will be harder. What that means is just wet sponge, like so, and we're back at it. Okay. Negative. Okay, now these switches, oh yeah, that's right. These are the new ones. These actually have, I just got these. These actually have little screw terminals on them, which I love. So what I'm going to do is I'm going to pre-tin the end of that wire, and then I'm just going to put it right into that screw terminal. Do that again. That doesn't look too good. There we go. That's a little better. Yeah. And then go right in here. Tighten it down. Yeah, these switches need to be tightened a little bit as well. Oh, yeah, they're not tight at all. Okay, let me go ahead and at least tighten that just a smidge. A smidge. What a weird word. A smidgen. I guess it's from smidgen. Anybody know where that word comes from? Smidgen. If you do, put it in the comments. Smidgen. All right. Okay. I wonder if you go into Starbucks and you say, I like a smidgen of mocha latte, if they just give you a shot glass full. All right, let's see here. So that goes there, and then the other negative goes to the other set, the third terminal. So third and fourth terminal get shorted, essentially, or switched. And that's what allows you to manually operate the pumps. Strip the end there. Okay. Twisty, twisty. Come on, baby. Let's do the twist. All right. No singing in the lab. Okay. Melty, melty. And hot melty pool. Melty, melty. Hot melty pool. Good. Into the switch. And tighten it down. Now, the other end, as we just talked about, goes to the third terminal. Let me see if I can get this on camera. Where am I? There we are. So we've got, okay. Positive going into the first one, negative going into the second. The negative from the second is being bridged to the third terminal, and the third and fourth terminals are the ones that are going to the switch. And that is the manual trigger for the timer. Now, this fourth terminal, the negative out, is the one that's going to go to the pump along with the positive. The first terminal and the fourth terminal are the ones that go to the pump every time when you're wiring one of these timers. That's the way I wire it in any case. You can wire it a few different ways. This is how I do it. And we're going to do the same thing to the bottom. We're just going to cut a piece of wire here, strip the end. Twisty, twisty. And strip the other end. Twisty, twisty. Melted pool of flux. Melted pool of flux. Dip the toes. Yep. And melty pool of solder. Tin the end. Melty pool, tin the end. And good. Now, go in, attach, or I'm sorry, put down a bit of pre-tin on the fourth terminal. Boop. That's it for a second. Good. Now, attach your wire. Just bend a little bit. There we go. Melty, melty. Melty, melty. Good. And put the other end into that switch. Oh, loose. Loosey goosey. All right, let's tighten that up just a smidge. That is finagly, finicky, fumbly. Wah, there we go. Okay, that's good. Nowza, we're gonna go here. Yowza, yowza, nowza. All right, go in here. Get that wire in there. I should probably have a pair of tweezers here for when I'm working on camera because my hands keep getting in the way. My apologies. There we go. And then do another one of these little wires. Little bridge wires. Here we go. Jumpers, what they're called. They're called jumper wires. When it's a short little piece of wire that goes from one terminal to another just to complete a connection, that's called a jumper wire. It jumps from one connection to the other. Okay, so we're going to make another little jumper. Oops. Need a little more off the end of there. Twisty, twisty. Come on, baby. Let's do the twist. No singing in the lab. Okay. All right, now. Melty, melty. There, and the other side. Good. And attach it to the switch. Bend that a little bit to get it in there. There we go. Oh, loosen a little more. Get on in there. There we go. Oop. And let's see. Let's get that right. Yeah. Now, see, this is what I was talking about. Since that second terminal, since I twisted that, since I did that twisty move around there, when I went to attach the other side of the switch to that same piece of wire, there weren't a whole bunch of pieces running everywhere. There was just the one piece that was twisted around, and then the one coming from the switch soldered right on top. Super clean, super simple, and it'll be a really good permanent connection. Okay? So, looks good. That looks good. Oh, I always shake them out like this too, because there, there could be a piece of wire or who knows what, a screw sometimes, or a piece of trimmed metal that I took off of there floating around in there. You just want to shake it out. Okay. Or blow it out, whatever. Okay, now we still have, we should still have power to this. Okay. Unless we shorted something out, I'm sure everything's fine. Looks good from here. Yeah, looks good. Yep, we're good. And now, final piece of the puzzle, we are going to send both timers to the output switch, which is a 4-pin connector right there. Okay, you see you have power here, and you have your 4-pin connector here. This one's the one that runs to the pumps. This one's where your power goes in. 12 volts and wiring to both your pumps. Okay. And this is called an aircraft style connector. They are literally used in airplanes. Let's see, because they are waterproof and very high quality. That is why they are used. Okay, let's do this. Let's line this up. So this is what I was talking about, polarity. If you look carefully here, you'll notice that, oh, I hope you can see this on camera. There's a little pin right here. Then there's a little pin there and there. The 3 pins. 1, 2, not pins, I'm sorry. Like a little tab, if you will. There's a little tab here, and then a little tab here, and a little tab here. this little tab is bigger. So that's how you line up the two. So when you go to, let's see here, where is it? Yeah. So this is eventually going to be your wire that goes in here, right? So when you go to plug this in, you twist it around until you find the right way up. That it can only go in one way because it's matched. Those little tabs are matched. Okay, so you put it in and you twist. You've seen these before. You've tried it before, and then you can twist it, and it's like this really, really good connection, right? Once you've got that connected. So you decide what you want each of these pins to do and write it down somewhere, and just, you'll always know what they do. And they can be either way, anything you do it any way you want. You should really write it down or record it somewhere so that if you ever have to work on it, you know what you did. Okay, so I'm going to use, for example, I'm going to line this up so that the big tab is on the let's see, how do I describe this? The largest tab is closest to the open side of the controller. So the largest tab is right here. That's how I'm lining it up, okay? So now when this goes like that, when that goes in there, I know which pin leads to which pin, and I can do the wiring correctly. Hopefully that makes sense. So the two top pins here, I'm going to send to the top timer, and the two bottom pins are going to go to the bottom timer. Again, first contact, fourth contact, first contact, fourth contact. Those are the ones we're sending out. Okay, so I cut a piece of wire, boop, and we strip the ends. Oops, that did not quite do it. Nope, what's happening? There we go. Okay, twisty, twisty. Twisting by the pool. All right, twisty, twisty, twisty. There we go. We're gonna pre-tin those again. Make ourselves a new pool here. Bloop, bloop. And melty, melty. Okay. All right, so now pre-tin, again, always pre-tin these things because it's gonna be so much neater and such a better connection if you pre-tin all of these connector connections, and anything large, any connector that's a little larger than the wire itself, you should pre-tin it, and it helps everything to flow like that. And then actually, I'm gonna twist this entire connector to solder it because it's just too hard to get to it otherwise. There we go. Now they're facing me. The two connectors I need to solder. And now, remember I said how I was going to use the top two for the top timer, so I need to twist it around again. Oops, whoa, I just bridged those two. That's not good. Yeah, these terminals are very close to each other. You have to be careful. You don't want to short them out, of course. Okay, let's see, where's that top terminal? Right there. Whoop, wow, that is really tight now. I'll loosen it actually. There we go. Okay, two top ones. Now, our top wire is going to go, I'm going to pre-tin connector number one, terminal number one, terminal number 4. 1, and uh-oh. Come on. There we go. Sometimes if the solder is not flowing very well, just hit it with a little bit of flux right on top and just re-wet it. And usually that'll take care of the problem. It's usually oxidized. That's what makes the solder joints not work well, is when they get exposed to the oxygen and they're cold. It's called a cold solder joint. Cold solder joint's no good. Okay, now here's a weird little issue I run into sometimes. Now this is why I do those little posts, because now what's happening is I'm trying to get two wires to attach to the same post, and they're fighting each other when I go to solder them. One's coming loose when I go to solder the other. So I'm going to twist them together. It's got to be the negative one, not the positive one. Negative. So I'm going to twist them together before I connect them to the post. Yeah, depending on how I do the soldering, sometimes that's necessary and sometimes it's not. This time it is. Okay, here we go. Alrighty, let's connect that right here. Boop. All right. Boom. And do this one. I just realized I never resoldered that center connector. Go. Okay, now I'm just going to trim this real quick because it's sticking out a little far. There we go. Remember, away, trim away from your work, right? Okay, now for the positive. Okay. Now this I should be able to attach without twisting it to the others, I think, because there's a lot of solder here. There we go. There we go. Yeah, good. Yeah, that's nice. And it's also not a bad idea to very gently, with your fingers, just kind of make sure that everything's good. Make sure that everything's solid. You know, just kind of very gently give everything a little tug or push or prod or pull it a little bit or whatever you need to do to kind of ensure that everything's tight. With your switches too, kind of tug on each one of those wires a little bit. Make sure everything's, you know, not going anywhere. Let's put it that way. Good. So that one's connected on the timer side. So now what we're going to do is run this right over to the output switch right here. Right, so that's there. You don't need to use more wire than necessary. Just custom trim it each time if you can. No need to waste. Okay, there you go. And if you've never seen wire, it just occurred to me a lot of people might not have seen wire strippers like these before. I honestly don't know what they're called. Catapult by Klein Tools, K-L-E-I-N. Yeah, these are great. I've been using these all my life. Not this exact pair, one just like them for most of my life. I just replaced this recently, but these are great. They have these little different sized wire openings. Let's see, right here, right? Different size openings for different sizes of wire so that when you go to trim it, it's exactly the size you need and you're not breaking the wire and it's a nice clean cut and it's all one action. You put the wire in and then it just strips it automatically. It's really cool. Like I said, I've been using them almost all my life. I had one pair for, oh my God, I don't even know, 20 years or something. And they're still good. They're around here somewhere, but they get dull and you can replace the blade. But at the time I didn't know that. And I just bought a new pair. Okay, so now, same deal. Decide which side is positive, which side is negative on your plug, and just test it with a meter before you hook everything up so you don't send the wrong polarity to your pump. But I'm going to do positive facing the power plug, negative facing the switch. Power plug being to my left, so positive to the left, negative to the right-hand side on the switch, towards the switch. I'm just kind of talking out loud as I make my decisions here. Okay. Now, I've never used this exact plug style before, which is why I'm kind of making this up as I go. However, I've already decided that I am going to be using this type of switch going forward, this type of plug rather, sorry. So from now on, most likely I will be doing this wiring exactly the same way every single time for consistency. So the positive will always be closest to the power plug. The negative will always be closest to the switch. And that's how I can build them and not screw them up. It's basically the bottom line. Yeah, consistency, you know, repeatability. That is what it's all about. All right, that one's hooked up. Now, again, I'm going to twist this around briefly as I solder these two wires, just because it's easier to access when I twist it around. Twisty, twisty. The other thing that's good about these wire strippers is that if you buy the kind that has the exact wire diameter or wire gauge size built into the blades, you know, with some different sizes like this, you are less likely to damage the wire itself as you're stripping the insulation. It's very easy to damage the wire when you're stripping wire. So to prevent that, a nice pair of wire strippers will go a long way. That's just my 2 cents. Let's see here. Negative, there we go, positive. Just keep an eye on which side is negative, which side is positive, because I just flipped the switch around. Oops, forgot to pre-tin this. Let's get our melty pool, and melty hot solder. Sounds like a party. You have melty hot flux and hot solder. I am so there. All right, put that to the side. Hot flux is my favorite. Okay, where is, there it is. Now, we're going to repeat the pattern that we already have established with the black on one side, red on the other. I'm just going to put both blacks on the same side and trim that a little bit. Both black wires on the same side and both red wires on the same side. I just started wearing contact lenses recently, but I only have one of them in right now. So I can see, but not optimally. Okay, one more, and then I don't have to see for the rest of the night. There we go. All right. Boom. Now, again, terminal 1 and 4 of the timer, right? Okay, so we're going to, oops, also I need to twist this around and trim this wire. Yeah, there we go. Very carefully, because now it's a short, whoa, yeah, short. I was trying to avoid that. That's okay. I was trying to leave the two wires remaining together, not tear them apart, but they were so short that I accidentally tore them apart from each other. That's okay. Doesn't change anything functionally. It's just an aesthetic thing. There we go. Okie dokie. Now we're going to pre-tin those. I just realized I was doing a little thing that I do sometimes. Sometimes what I'll do is what I just did. I'll go up, I'll heat the wire, and then literally while it's in the air, I'll just dip into the pool. I'll just be like this. It's so silly. They're little things I do just to save time, you know. But yeah, move these outside of your work area. And whoops, message. New phone, who dat? Let's see here. Who's that? Oops, come on. I don't need to know right now. Okay. There we go. And final connection. We are hooking positive to positive, or I'm sorry, the one side of this connector to the positive of the timer, and then the negative to the last terminal, which is the switched negative. There we go. Boom. And now we have a complete timer, believe it or not. Now, well, I don't have the other stuff built right now, so I can show you right away. But if you tune into the next episode of this Aero Lab, I will show you hooking this up to the pumps and actually running the pumps with our new timer. So, oh, and also I will show you how I do these little, what do you call them? Brass, what the heck are they called? It's what the thumb screws screw into, the brass knurled, oh, shoot. Yeah, whatever these metal pieces are called, leave it in the comments. I don't remember what they're called offhand. You heat them up and you put them into the plastic, and then it allows you to use something like the thumb screws to attach all your stuff, right? And I can show you how I do these. It's pretty fun, actually. But that is the next episode. So yeah, the controller works really well. It's great. The wiring's all good, nice and neat, ready to go. And like I said, on the next episode, I will show you guys a bunch of other stuff, but we will also finish this up, hook it to the actual pumps, and I'll show you how all that works. So until next time, thank you for joining in. I'll take a look at the YouTube comment. Holy cow, that's a lot of, you know what, before I go, let me take a look at these comments. I didn't realize there were so many comments. Let's see here. Let me move this a little closer. Wow, blowing up. Carbon fiber plastic, yes. Solid orifice pin, yeah, they didn't return my emails. Yeah, you first ordered anything else. Okay, well, Andrew Bello, I will definitely, you will know when they're available. It's going to be not too long, probably about maybe a month from now, I'm thinking. They will be available. Ultrasonic tip, shockwave, yeah. Cool. It's an external. Hold on, let me see this here. I've got some questions here I didn't realize. Let me see if I can answer some of your questions here. Ultrasonic tip, the shockwave kickback hit the mix, exciting to tip. Yeah, exactly. Such a great design. Need to be in an external bucket and the fog forced into the root bucket via HP. No, I don't think so. Okay, I know what you're saying. About the okay, the question is here, in other words, with the combination of 45 psi air pressure and the liquid pressure and the dry fog, is that so much pressure inside of the root zone that it's damaging the fine root hairs? Not that I can tell. Okay, that being said, inside of the bucket, what I do to sort of alleviate the problem you're referring to is, first of all, if it's a medium pressure or a low pressure, I aim it right at the root zone. No problem. It's not going to do any harm. You need to get it there anyway. If it's a dry fog, a higher pressure, 45 psi with air behind it, so that kind of a dry fog, I will aim how do I demonstrate this? I will aim, okay, normally it's aimed towards the root zone. Get this on camera. Normally it's aimed like in the middle, like that. Yeah, aim towards the root zone. When it's high pressure, I'll aim it like that, towards the edge. Now what happens is you'll still get all the fog, because the fog goes everywhere, absolutely everywhere, including shooting out of the top of the bucket. It's pretty dramatic, but it won't hit the roots directly. So you're just sort of, normally it's like that. You're just aiming it like that from the side so that it doesn't directly hit the root. That's it. And that seems to take care of everything just fine. If you look at some of the photographs on YouTube, I'm trying to remember where they are. There's this one photograph where I'm pulling a lid off of a bucket and you can see the whole root ball underneath of it. And that was a really good, if you zoom in on that, you'll see that was a good example of what happens when you got that medium pressure, 45 psi, that huge root ball and all those fine hairs. The setup was exactly like I'm describing for that grow. and the nozzle was just aimed a little bit off center. And I actually had a fan running on that one too. In other words, it would spray, and then in the time in between spray cycles, there's a tiny little 40 millimeter fan that would ventilate the root zone. That was the only other difference with that one photograph. And that's a design that I'm going to be bringing back out in the market soon, the one that includes the fan as part of the design. Because I'm a true believer that is a huge advantage. So in other words, instead of just wetting the roots and then letting them air dry on their own in between cycles, this one wets the roots, and then the fan turns on inside the root zone and kind of forces the drying cycle, and then sprays again, forces the drying cycle, and so forth, on and on and on. And that seems to work really, really, really well. So I'm looking forward to doing some experimenting with that this spring, and we're going to see how far we can take that with the fan and see how many little root hairs we can get. It's going to be a lot of fun. So let me take a look through these other questions here, or comments rather. What a strippers ever made. Yeah, they're great. You're talking about the wire strippers. Yeah, these things are the bomb. Let's see here. Let's see. Found the company to fry a cultivar. Oh, interesting. Try on these cutting edge commercial airplanes. Nice. Oh, yeah, I'll check it out. I'll check it out. 1 second. I just need to go over here and turn something off. There we go. Don't want to get any copyright violations here. Didn't read my stripper comment. Yeah, coincidence. Nice. Did I miss a stripper content? Where did I miss a stripper comment? Oh, shoot. I hate to miss a stripper comment. All right. Until next time, same bad channel. You know it. All right, root zone. Exactly. Yep. Root zone gets stagnant. Yeah, we do try to avoid that. Yes, exactly. That's what I believe has been happening. And my feeling is, and my observation is, my hypothesis, whatever, that the fan in between the spray cycles, the fan helps to prevent root rot as well, because it is a combination of the temperature with the high humidity levels over a sustained period that tends to lead to the favorable conditions that promote Pythium root rot. So if you can dry a little more completely in between the cycles, my feeling is, my theory is, a hypothesis is that it's a much healthier way to grow. So we're going to play around with that, and that's coming up. The next episode, we will be checking out the completion of this unit, which is going out to a customer, and we'll be doing plenty of other stuff. So thank you for checking it out. Please remember to hit like and subscribe, and check it out next time. I do appreciate you being here. Thank you, everybody. Andrew, yeah, thank you for your comments. I really appreciate you. Thank you, and we'll catch you next time. I hope everybody has a great weekend. Go grow something. All right. How do I turn this thing off? Just pull the cord out of the wall. All right. No, we won't do that. Let's see. I could figure out how to end this program. I would probably do it. Jeez, where's my... All right. Transition and fade to black.